This is the last topic which we were doing, right? Yeah.
Yeah.
And it was, I need to actually know about the file. So, which topic was that? It was atomic structure?
Yeah.
All right, fine. Just a minute then. Mm,
We finished it.
we finished it, right? Okay. So, which one do you want to do next? The very next topic?
Can we start organic chemistry?
Sure, sure. Why not? Just a minute then. Uh, Organic chemistry. Okay. That is, let me ask you, that is section 3, chapter number 11.
Yeah.
Okay, fine. Okay, just a minute. All right. Organic chemistry. Okay. So I'll make a new file then. Organic chemistry. Organic chemistry. And today is what? 11th January. 11th January 2026. All right. All right, organic chemistry. Zina, organic chemistry is basically organic means study of carbon or carbon compounds. That is organic chemistry. Yeah. And
Yeah.
as far as carbon is concerned, basically it's about carbon. It's about carbon or carbon containing compounds. Carbon containing compounds. All right. So if we talk about specifically about carbon, carbon is 6,612. Now, if we do the electronic configuration, what would be the electronic configuration for carbon in simple way? 2 comma
4.
4. That means four electrons in the valence shell. Valence shell. Now, 4 electrons means 4 bonds. Yeah, that means that carbon can make 4 bonds. Why 4 bonds? Because you know that in the valence shell there must be 8 electrons, right? So if 4 electrons are with carbon, then it needs 4 more electron. It needs 4 more electrons to complete the octet. Are you getting my point? Right? So that means that carbon is going to form how many bonds? 4 bonds. So 4 bonds can be in 3 ways. 4 bonds can be made in 3 ways, and there is another way as well. I'll show you that as well. So the first way could be carbon would have 4 single bonds. So what is it? It's 4 single bonds. When I say that carbon is going to form 4 single bonds, that means it's an alkane. It is an alkane, right? Now, if carbon doesn't make 4 single bonds like this, the other way to make 4 bonds could be like this. That means that it will make a double bond and 2 single bonds, right? Again, it is one, two, three, four. But what's the difference between this and this? That is, all the 4 bonds are single, and here 2 bonds are single and 1 bond is double. All right. So when this is the case, I am going to say that there are 2 single bonds and 1 double bond. So if a compound contains a double bond, that is called as an alkene. All right. So it's ane, it's ene. Now the third one could be like this, that the carbon is again going to make 4 bonds, but it will make the 4 bonds like this. So, like this. So, what is it? That it is one, two, three, and four. But out of these 4 bonds, one is a triple bond and one is a single bond. So, I can write it like this, beta. That is one single bond and one triple bond. So when there is a single bond, we call it single bond, we call it alkane. When there is even a one double bond, we call it alkene. And when there is a triple bond, we call it alkyne. All right. Now, all these are actually open structures. These are open structures, or they can also be called as aliphatic compounds. Aliphatic compounds. Now, there is an other type of structure which is called as closed structure, the fourth type, or it is also called as a ring structure. All right. And for example, the ring structure could be carbon 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 6. So now if you are, this is called as cyclic structure. So, closed or ring structure can also be given an other name that is called as cyclic structure. Now, in this cyclic structure, we are again having different ways of satisfying the valency. So, if I'm going to talk about the cyclic structures, which are in contrast to the open structure. This could be like 1, 2, 3, 4, 5, and 6. Now, if you want to satisfy the valency of carbon, this carbon is one valency, second valency, third valency, and fourth valency. And these valencies would be satisfied by hydrogen. Are you getting my point, Zena?
Yeah.
All right. So now, what does it mean? That carbon is forming two single bonds with other carbon atoms and two single bonds with hydrogen atoms, right? So, same is the case here between this one, hydrogen and hydrogen, hydrogen and hydrogen, hydrogen and hydrogen, hydrogen and hydrogen, and hydrogen and hydrogen. So now each pick any carbon and it will be connected to 1, 2, 3, and 4. So there are four single bonds, just like in alkane. The four single bonds are there, but these bonds are in a form of a cyclic structure. So if I am going to combine this together, it becomes C6 and H12. So this is the formula. There are other ways to make the cyclic structure. So this is called as cyclohexane. Now, if I draw the same structure, if I have the same structure, uh, let me show you. All right. So if I have the same structure, what I can do is I can make one double bond and I can omit two hydro. For example, if I make this a double bond, so now check the valency carbon 1, 2, 3, 4. So it needs only one more bond. That means that this bond can be crossed out. So have a look here. I will make this bond not present. I'm going to omit this bond and I'm going to omit this bond as well for this one. 1, 2, 3, and 4. So this bond will be omitted as well. So I'm going to omit this bond. I am sorry I can't rub it because I have copy pasted. Yes, I have copied and pasted it. So that's why I can't rub it. But now this is the compound. So what is it called? Now it is called as cyclohexene. Now
Hexene.
yeah, cyclohexene because there is a double bond here. All right. So there is another way of making the cyclic structure like this. For example, 1, 2, and 3. This is called a cyclopropane. Now, in order to satisfy the valency, I need to put two hydrogens here, two hydrogen here, and two hydrogen here. So this is called as cyclopropane. I hope you are getting my point. Yes?
Yeah.
In the same way, you can make cyclobutane as well. So this is cyclobutane. All right, cyclobutane. So this was all about the starting of the organic chemistry. So that is now, you are not going to study in these chapters, but when we go further along in the second part, you are going to study about another way of the another form of the compounds with three double bonds like this. That is, this is a double bond, this is a double bond, and this is a double bond, and there would be six hydrogens around them, around the carbon atoms. And this structure, I'm going to differentiate it from the next one. And this structure is called as benzene. Benzene. This structure is called as benzene, and it comes under aromatic compounds. Aromatic compounds, but we are not going to study about this right now because this comes in the second part. All right, so this was all about the cyclic structure. So I think this classification is clear to you. Yes?
Yeah.
Any questions, Zena?
No.
All right, good. Okay, now what the next thing I need to mention, because it's an introduction chapter. So in the introductory session, I am going to tell you all about different things which we are going to come across during our lectures. So the second thing is formulae. The second thing we are going to do is formulae. formulai. Formulae. Now, how many types of formulae are there? So now let's have it. Let's have these. Number one, it's the empirical formula. Number two is molecular formula. Number three would be displayed formula. Number four would be skeletal formula, which is called as bone structure as well. Number five would be three-dimensional formula. Now I'm going to discuss what are these, all right? So first of all, this is the as far as formulas are concerned, empirical formula for this shows the simplest ratio. This shows the simplest ratio of atoms. Simplest ratio of atoms. I'm going to discuss them in detail. Molecular formula is the actual formula. Displayed formula is the way in which all the bonds can be seen easily. All the bonds can be seen. Skeletal formula, that means we don't show carbon and hydrogens. We simply use corners or lines. I'll make this clear afterwards. Three-dimensional formula, that is with wedges and dotted lines. Wedges and dotted lines. Now let me explain them one by one. For example, I have made this. Now, what is this, beta? This is the displayed formula. Are you getting my point? So, if
Yeah.
I pick this up, let's suppose if I pick this up, this is actually, all right, this is actually what this is. Let me tape this up, otherwise, it is going to disturb us. So, this is actually the displayed formula. All right. Now, if I want to change this formula to molecular formula, I am going to write how many carbons I need to count them up. So that would be 1, 2, 1, 2, 3, 4, 5, 6 carbons. So I'm going to write C6. And how many hydrogens are there, Bete? 12 hydrogens around it. So this would be C6H12. So this is the displayed formula. This would be the molecular formula. Total actual formula, that means total number of total number of atoms. For example, there are six carbon atoms, so I have jotted them down together, and there are 12 hydrogen atoms, so I have written it together. So this is the molecular formula. Now, molecular formula. Now, as I told you, that empirical formula is the simplest ratio. So the simplest ratio for this formula would be 6 times 1 is 6 and 6 times 2 is 12. So for this molecular formula, the empirical formula would be CH2 for this one. Are you getting my point, Zena?
Yeah.
If something is not clear, you may ask better.
It's fine.
All right, good. All right, so now comes the or for example, I'm going to tell you about a simple thing that is just to explain three-dimensional formula. I'm going to explain, for example, methane. So methane is like CH4, the simplest, and methane as it ends in ane. So that means I have written an alkane. All right. And you know that in case of alkane, all bonds are single. So I will write it like this CH4. So this is actually the displayed formula. You can see this is the displayed formula, right? But if you want me to show the actual dimensions, then I need to make this, which is absolutely correct representation. So this would be like this, and then this, I'll tell you in detail, and then, oh, and then this. So this is actually a solid line on the plane. This is also a solid line on the plane. This is called as wedge, going out of the plane, going out of the plane in forward direction. This dotted line is also going out of the plane in backward direction, going out of the plane in backward direction. So this is actually what this is the 3D. Some books it is written as 3D formula like this. All right. So this is actually the representation. So let me highlight it: solid line, dotted line, and wedge. Always keep this thing in mind that wedge goes out of the plane in forward direction and dotted line goes out of the plane in backward direction. So actually, we have already discussed that. So this is actually the tetrahedral structure. All right. So this is actually tetrahedral structure. And this is the structure of methane, which is an alkane. Now, tell me, I have given you the example of empirical formula, molecular formula, displayed formula. I haven't done skeletal formula yet, but I hope three-dimensional formula. All of these are clear, or do you want me to explain something to you if it is not
They're
clear?
clear. They're
Good.
clear.
Well done. So now the next thing is, let's suppose I am going to take a very simple example of alcohol. Now, alcohol, the type of alcohol I'm going to take is ethanol, right? So if I write ethanol in the center, and then I represent it with different forms. So the molecular formula of ethanol, okay, that could be what should I say? Anyway, so if we start with this molecular formula, So I'm going to write C2H5OH. I have to keep this OH separate because it's a functional group. I'm going to discuss about them later. All right, maybe you have some idea of alcohol. Yes, Zena? Yeah.
Yeah.
So this is actually, so this is what? This is the molecular formula, or you can also call it, yes, it's a molecular formula, but it can be written as C2 C2860. This can also be the representation of ethanol, combining all the hydrogens and carbons and oxygen. So it becomes C2860. This helps us in getting the answer for the isomerism thing. I'm going to discuss it afterwards. But this could be one representation. If I'm going to write it like this, in this case, if you are going to make it simple, 2 times 1 is 2, 2 times 3 is 6, but O cannot be done. So if you want to write the empirical formula for this compound, that could be CH3O. So that could be the empirical formula for the same compound. But I have to write O with it because O cannot be shortened. Now, the next thing, if I write it like this, CH3CH2OH, so that would be like this, like this. So this is actually the displayed form of the formula, or to be very specific, I can do it like this as well. So it clearly shows that all these bonds are the single bonds. So oxygen actually makes a double two bonds. So this is the first bond and this is the second form bond. So this is another way of representing it. So what is it? It's, you can call it a displayed formula. Now, three-dimensional formula would not come in this case because 3D, it is not 3D, it's a planar molecule, so everything is drawn on the paper. Nothing goes out of the plane, right? So then comes the next formula, which is called a skeletal formula. Skeletal. Yes, a skeletal formula. Now, the skeletal formula would be like this. 1, 2, 1, 2, and then OH. So, as I told you earlier, that I'm not going to mention the carbons. So, where are the carbons? Here are the carbons. So, these joints, let me highlight them. This one and this one. These are the carbons. And each carbon is surrounded by four hydrogens, in this case, one, two, three, and fourth would be this bond. Same goes with this carbon, one bond, this carbon, one bond, two bond, and what else? Um, three bond and four bond, and then comes this O and H. I'm going to show this because this is the functional group. So in the skeletal formula I need to show the functional group. So that means that, for example, if I will write it like this, I need to write the skeletal formula. I'm writing it again. That's it. O and H, like this. Or you can put a line. It's entirely up to you. So this would be read as ethanol. And this is the what skeletal formula. Now tell me, is it clear, Zena, or should I explain it in another way so that it will get clear to you?
It's clear.
All right, fine. Now, all these formulae as are very important. Now, for alkanes, let's suppose if I make a W, some more, some more skeletal formula. If I make this V, can you tell me what is it? And if I make W, what is it? Can you tell me?
Is the first one
Yeah, the first one is
pentane?
what? Sorry?
Pentane.
The first
I
one,
mean
this one?
propane. Propane.
Propane. One, two, three. Are you feeling well, Zena?
Yeah.
All right. So this is propane, bitte. So have a look. This is carbon, carbon, carbon. As there are three carbon, well done. It's propane. And this one, bitte. The other one,
Uh,
W.
pentane.
Well done. It's pentane. And what is it?
Butene.
Just to make a small correction, that would be butene because the double bond is between carbon number 2 and carbon number 3. Are you getting my point? All right.
Yeah.
And I will start the numbering from this side, bete, because if I start the numbering from this side, one, two, three, then and then four in this way, right? So then the double bond would be, I think it would be the same from both the sides. One, two, three, four. So that would be the double bond is between carbon number 2 and carbon number 3. So we are going to write butene. I hope it's clear, right? However, if I change this W like this, then I am going to put the double bond here. Then what do you call it? Pent?
Uh, pent 3ene.
Pent 3 in, which would be, you are starting the numbering from here, beta. One, two, three, four, five. You have to keep this thing in mind that we will start the numbering from that side from where the double bond is closer. So that means that instead of numbering it like this, I'm going to number it one, two, three, four, five. What's the advantage is what is the advantage of numbering it from the right side? The advantage is that the double bond would be between the second and the third carbon atom, right? And if I will start the numbering from left side, the double bond would be between one, two, three, four, third and fourth carbon atom, right? So that means that I will not start the numbering from left side. I will start the numbering from right side because in this way, the double bond would get a lower value that is 2. Are you getting my point?
Yeah.
So that would be pent to in. And I need to put these small hyphens in order to separate them out. I hope it's all clear. Yeah?
Yeah.
All right, fine. Now I'm going to. I have discussed the formulae. I have discussed the um, cyclic compounds, aliphatic compounds, cyclic compounds. Now I am going to discuss the functional groups. All right. So let's start the next heading, functional groups. Now I'm going to discuss them in detail. It would be quite a lot, so you have to be very careful when we would be doing this, right? So that would be like this. Let's suppose one thing more. Let me. All right. So before functional groups, let me tell you about the carbons. That is one carbon, two carbon, three, four, five, six, seven, eight, nine. It depends upon the number of the carbon atoms present. So if we talk about if there is only one carbon in the compound, this is called as meth. If there are two carbons in the compound, that is called as eth. If we check this, now have a look. This would be here it is. Uh, C H3, CH2 and OH. How many carbons are there? Two carbons are there, so the name is ethanol. Ethanol. So the name is eth. Eth. So here it is eth. Three carbons prop, four carbons but, five carbons pent, six carbons hex, and seven carbons hep, eight carbons oct, nine carbons neo, and 10 carbons deca. Nano or neo, and the 10 carbon would be deca, right? So this is about the number of carbon atoms, and it's entirely up to you whether you want to divide it into alkane, alkene, or alkyne. For example, if I'll circle prop, then it could be, if in terms of alkanes it is called as propane, in terms of alkene it will be called as propene, and in terms of alkyne it will be called as propine. I hope you are getting it right.
Yeah.
Now comes the functional group. So when we talk about the functional group, a functional group is something which imparts properties to the compound. Functional group is a special type of group which impart properties to the compound. Now, for example, I'm writing functional groups in the center, and then I will also make a table, but afterwards, right now, I'm going to discuss the functional groups. All right. So the very first group I'm going to mention, which we have already done, that is number one, alkane. Alkane. This is the functional group number one. Alkane ends in ane. So what is it? Actually, all bonds are single. All bonds are single, and it ends in ane. Ends in ane. The example is, for example, I'm going to write one, two, three. So this is propane. So the name is propane. All bonds are single. If it's clear, then I will go to the next one. Yeah?
Yeah.
All right. The next one is alkene. Alkene. So again, it's a hydrocarbon. Yeah, let me mention it. It's a hydrocarbon. Hydrocarbon is a compound having hydrogen and carbon only. So this is the definition of hydrocarbon. What is hydrocarbon? A compound having carbon and hydrogen only is called as hydrocarbon. All right. So alkene, all uh, at least, sorry, at least one double bond, at least one double bond in the whole compound. If there is one double bond, that is called as alkene. So taking the same example of three carbons, so one, two, three. So one bond must be double. Now this would be like this: one, two, three, four for this carbon. For this carbon, one, two, three, four. For this carbon, one, two, three, and four. So this is beta alkene, which is called as propene. So I can write it like CH3 CH double bond CH2. So this is the formula for propene, and you can see that there is one double bond, and because it ends in ene, so I'm going to write propene like this. Now that this is the second functional group, so number two. Now comes number three. Number three for functional group is halogenoalkane. Halogenoalkane. Now, what's the difference between them? The halogeno is a separate word and alkane is a separate word. So, halogeno means group 7, which is actually fluorine, chlorine, bromine, and iodine. And alkane is means that alkane, that means all single bonds having carbon in it. So this is alkane. Now, if I replace one hydrogen with any one of these, for example, fluorine, so it becomes CHH. Use the same colors. Sorry. CHHH, and I will write F. So this is halogenoalkane. And what is which halogeno? Uh, what is it? Fluoromethane. So now this is now have a look. Halogeno. So what is halogeno? Fluoro. What is alkane? Methane. Fluoromethane. Or if you are going to replace this by Br, then it becomes bromomethane. So this part is actually halogeno, and this part is the alkane part, which is actually the parent. So the parent is alkane, and if you take two, we will do this as well. So this would be one, two. Now have a look. All of them are hydrogen. Then it is ethane. Now if I rub one hydrogen and I replace it with Cl, it becomes chloroethane. chloroethane. So first halogeno part comes, and then alkane part comes. And when you combine halogeno and alkane, it becomes halogeno alkane. Halogen, this part is halogen and this is alkane. So it is called as halogeno alkane because the parent is alkane. Is it clear?
Yeah.
Good. Uh, Next is number four. So now when we talk about number four, that is alcohols, we have already done that. Alcohols. Alcohol means OH group. That is, again, take an alkane. I am taking ethane again. Now again I am taking ethane. Now if you replace one of the hydrogen with X, that is halogen. By the way, group 7 is also called as X group, that X represent halogens, right? So this is not cross, this is X group. Now, if I replace it with X, it becomes halogenoalkane. Now, instead of replacing it with X, if I replace the hydrogen with OH, that becomes alcohol. So again, the parent is alkane. So that is why, because the parent is alkane, it is also called as alkanol. Alkanol. You have to make it end in ol because alcohol also ends in ol. So it can be called as alcohol, it can be called as alkanol. And again, as there are two carbons, the two carbons are called as ethan, and then you will add ol, so it becomes ethanol. So this is actually the representation of this. And by the way, this whole thing can be called as R group. Do you have the idea of R group,
Yeah.
Zina? All right. So this is called as R group. Okay. Now the next, the fourth one. Now we are going to go to the fifth group. So the fifth group beta is called as what it is called as carbonyl group. Carbonyl group or carbonyl group. Carbonyl group actually divides in two categories. That is, number one is aldehyde and the other one is ketone. All right, always keep this thing in mind. Aldehyde ends in Al, which are the first two letters. Most of the time, we take the last two letters or three letters. For example, in this case, last two ol, now last three in. All right, again, last three in. So, but here we in alcohol, instead of three, we take two ol. But in case of carbonyl compounds, we take the first two letter for aldehyde. However, we will follow the trend and we will take the last three letters for ketone. Now, carbonyl compound can be divided into aldehyde and ketone. Now, first of all, let me tell you what is a carbonyl group. Carbonyl group is like this, that two valencies of carbon must be satisfied with oxygen and the rest of the two valencies are open. Now, what do I mean by this thing that the rest of the two valencies are open? That means you can put the element according to your need. For example, so this is something must for an aldehyde and ketone. Now, if you want to change the carbonyl group into an aldehyde, what you need to do is you need to block one of the valency with hydrogen. This is blocked. Let me write. This is blocked. What is the meaning of blocked? Blocked means that you cannot move this hydrogen. Now, this valency will always be with hydrogen. However, this valency, the other valency is open. You can put hydrogen here or you can put any other element, for example, any other R group, not any other element, any other R group. But this valency must be blocked with hydrogen. If this is the case, so that is why it is called as CHO. CHO. Where is C? Here is C. Where is H? Here is H. And where is O? Here is O. So in some books it is written as dash CHO. So this is called as aldehyde. For example, if you want me to give another example, the other example could be like this. Just a minute. Hmm. The other example could be like this. For example, if I have, I'll keep it open so that I can write anyway. So this is C double bond OH. Now I have to block, in order to make it aldehyde, I have to block it with hydrogen. But then I can write any other alkyl group. For example, I have written this alkyl group which is called as C2H5. Now have a look. This is one carbon, two carbon, so C2, and 1, 2, 3, 4, 5. So C2H5. C2H5 is called as an ethyl group. How is it made? I'll tell you later about this. First, just let me explain it, then I'll go back to the R group. So what is it? It's an aldehyde. Now, how you are going to name it? You are going to count the number of carbon atoms. So one, two, three carbon atoms. Three carbon atom is called as propan, and because it is an aldehyde, so it is called as propanal. So it becomes propanol, and this is actually what this is, aldehyde, because you cannot move this hydrogen. It's entirely up to you. For example, if you want to say that, miss, what would happen if I am going to put the hydrogen on both the ends? Doesn't matter. If you are going to put hydrogen here and this is blocked, so this has to come anyway. If you write a hydrogen here, then again it would be the simplest type of aldehyde, aldehyde. And what would be the name of it? As there is only one carbon, so it is called as methanal. So this is called as methanol, right? Or methanol. So again, this is the aldehyde, right? And now if you want to make ketone, the the main group would remain the same. The main good group, which is the carbonyl group, would remain the same. So C double bond O, this is the carbonyl group. So it would remain the same. But for ketone, the condition would be both the valencies of carbon must be satisfied with the R group. That means in case of aldehyde, there is a blocking with hydrogen, but in case of ketone, there is no blocking, and both the valencies are open, and you can need to put R group. Never ever put H here, either on this end or at this end. You will never put an H. You will put R group. Both these R groups could be the same or they could be the different. So if the I'm going to give the example of both. If the R groups are same beta, then you will put RR. If the R groups are different, then you can put R and R dash. First, I will give you the example when both the groups are same. So the simplest alkyl group you have is CH3, which is called as methyl group. Now C double bond OC, and as I told you same, so I'm going to put CH3 here. By the way, technically speaking, it's not a big thing, but still, technically speaking, it should be written like this because the bond is always between carbon and carbon. So technically, it should be written like this because this shows that the bond is between hydrogen and carbon, which is not the case. But if you write it like this or the other way, it's all fine, right? So I'm going to follow the traditional way. Sorry. I'm going to follow the traditional way, which is this. So both these groups are the same. Now how I'm going to read it? One carbon, two carbon, three carbon. So this is proper propan. And as I told you that ketone ends in on, so I'm going to write on. So this is propanol. This is propanol. By the way, this is the start of the ketone. However, the start of the aldehyde is methanol. This one. The start of the aldehyde is methanol, or both the valencies of carbon would be satisfied by hydrogen. But the start of the ketone is propanone. So that means this is the first ketone. So this is the first ketone. because you cannot make ketone smaller than this. How can you make it now? Look, you need to put an R group here, right? You cannot put hydrogen here. So when the simplest R group is CH3, so if you put CH3 on both the sides, so there would be how many carbon atoms? Three carbon atoms. So that means it's a propanone. The start of the ketone is propanone, and the start of the aldehyde is methanol, in which there is only the carbon of the carbonyl group is present, and rest of the valencies are satisfied by hydrogen. For example, here. Is it clear, Zena?
Yeah.
I hope it's not very gross for you. You are understanding what I'm trying to tell you.
Yeah.
All right, good. So we are done with aldehydes, we are done with ketones. Now the next functional group, which comes uh, fifth, sixth group, that is actually the carboxylic acid group. So now we are going to do group number six, which is the carboxylic acid. Carboxylic acid. All right. Now, if I want to first of all, let me tell you about the functional group that is C double bond OH. So this is the functional group of carboxylic acid. Now, there is only one valency vacant, this valency. This is vacant. Now, you can satisfy, it by R group, or you can satisfy it by hydrogen. Now, if you are going to satisfy it by hydrogen, you have made the simplest carboxylic acid. So let's start it with hydrogen. So that would be HC double bond OH. Now I have put hydrogen. So how many carbon are there? How many carbons are there in this compound, Zena?
One.
One. So first carbon beta is called as meth. So I'm going to write the name methanoic acid, because carboxylic acid they end in oic acid. So this is the simplest carboxylic acid. By the way, this acid is present in the sting of the ants, which is called as methanoic acid, or it is also called as formic acid. And it's just for your knowledge, not to memorize it. Now, the next one is what? The next one is, now first I put H, now I'm going to put R group. So again, the carboxyl group would remain the same like this. And now I'm going to replace it with the R group. And I'm putting the simplest R group, which is CH3. Now, how many carbon atoms would be there? This is the first carbon atom. This is the second carbon atom. So there are two carbon atoms. So I am going to write it ethanoic acid, because you know that when there are two carbons, we have already discussed it, when there are two carbons we call it ethanoic acid. So as I told you that it ends in oic acid, so that's why it is called as ethanoic acid. Does it make sense, beta?
Yeah.
All right, so this is the fifth group. Now, in your syllabus, there are actually eight, nine groups. So I'm leaving um, one group here. I'm going, eight groups are there. I'm going to write it because there is a space left. However, keep this thing in your mind that I haven't discussed the homologous series yet. I am going to discuss it when we go after further along. So I want to basically introduce all the topics which are there in your syllabus, right? So the last functional group which should be mentioned is ether. So the next group which is important in your syllabus is ether. So ether is OR, that is dash OR. So this is the functional group. Now what you need to place here, you need to place here R. So that is ROR. That is the functional group. I'm going to shift it a little bit to this side because I think I need to write one more. Carboxylic acid should be there. So I'll make a pink line here so I can differentiate it. All right. So ether. So what is ether, beta? Ether is ROR. And for example, if I replace this with CH3 and if I replace this R with CH3, it becomes CH3OCH3. So what would be the name of it? Because both of them are a methyl group. So I'm going to write the name as dimethyl ether. There is no specific ending for ether. It ends in ether. For example, if you check alcohol, alcohol ends in ol. That is ethanol. If we talk about carbonyl group, it has specific ending for ketone and aldehyde, which is al. So if you make a ketone, which is called as propanone. If you make an aldehyde, for example, this one, it is called as propanal. But ether doesn't have the ending like this. So this is called as dimethyl ether. For example, if I replace this R with C2H5 and the other R with CH3, because you know I need to write ROR, right? So if I replace it like this, then what does it mean? Now, this is called as beta. This is the ethyl group. This is the methyl group. Now we are going to write it alphabetically because ethyl, E comes before methyl M. So I'm going to write beta ethyl methyl ether. So this would be the name of this ether, that is ethyl methyl ether. Is it clear, beta?
Yeah.
All right. Now the last one is what was I talking? I was talking about which group? Aster. So the next group is Aster. Now this is so let me write sixth. This one is seventh group, and this one is eighth group, right? So the eighth functional group we are going to come across is Aster. It ends in eight. It ends in eight. So for and what is the functional group? The functional group would be this OR. So this is COOR. This is the functional group, right? Now, what's the difference between, don't confuse it with the carboxylic acid. Carboxylic acid is C double bond O OH. So it is called as C double bond O OR. So this is OH. Let me highlight this. This is OH and this is OR. By the way, one thing more I forgot to tell you, that is, when we talk about carboxylic acid, so carboxyl means C double bond O. All right, so this is carboxyl. Carboxyl is actually the combination of carbon and oxyl. So carbon is this, and oxyl is this, right? So carboxylic acid, just for your knowledge. And now this is the ester. And now this valency is open. This valency can be satisfied by hydrogen or R. Now, if I will make the simple ester, I will replace this valency with H, and it would become HC double bond O, and this R could be the simplest R, CH3. All right. Now, whenever you write this, when we will make it, when we will make it, then I will tell you that what would be taken out from the alcohol and what would be taken out from the acid, because ester is formed by combining an acid with an acid with an alcohol. So I'm not discussing the naming right now. I will discuss the naming afterwards. So I'm going to put an exclamation mark here because I am not explaining it right now. I will explain it afterwards when I will be telling you how to make it, right? So this was all about the functional group. Now tell me, if something is not clear, Bete, I can explain it to you again.
It's clear.
Good. Now a simple discussion about the R group. I hope I am not very fast, Zena. If you think so, I
No.
can slow down.
No.
All right. Okay. Now the next discussion is about the R group. R group. What is an R group? R group is called as alkyl group. What is an alkyl group? Now, if I write the first alkane, that is methane. All right, this is called as methane. Now, if I remove this hydrogen, if remove this hydrogen, then the rest or the remaining thing is called as an alkyl group and R group. So methane, from methane, which alkyl group can we make? CH3, which is called as methyl group. So alkyl group is made by removing one hydrogen, because then we have to combine it with some other group. For example, when I say ROH, which is an alcohol, yeah. So this is an alcohol, ROH. So what is R? This is the alkyl group, right? So let's suppose if we take this group, so this is methane. The overall concept is that it's methane. If you are going to remove one hydrogen, the leftover thing will be called as alkyl group. Because if I will write full methane, then where I will place this OH? I can't place it anywhere, because the valency is already satisfied. So that means I have to remove this H, and then I will put the OH here, and it becomes methanol. So which alkyl group is present in methanol? R group, which is methyl group. All right. So if you make ethane, this is ethane, that is C2H6. Now, if one hydrogen is removed, then it becomes an R group, and at this point you can attach it to anything. So this is the R group, and this R group is called as ethyl. So ethane is the alkane, it's the alkane, and remove one hydrogen and it becomes an alkyl group. Is it clear, beta?
Yeah.
So wherever you write, so what is it now? It's C2H5. So beta, this is C2, 1, 2, 3, 4, 5, C2H5. So this is the alkyl group, right? So if I will make the list of alkanes here and alkyl groups here, so it will be clear to you. So I will do it for 4, 5 names. So the first name is methane. The second name is ethane. The third name is propane. Fourth name is butane. Fifth name is pentane. So that would be methyl. Oh, that would be methyl. This would be ethyl. This would be propyl. And this would be butyl. And this would be pentyl. Now, if we talk about the names, this is CH4. C. I'll use a different color. Just a minute. Sorry. So this would be CH4. This is C2H6. This is C3H9. And this is C4H10. And this is C5H12. Now for this, I will simply remove one hydrogen to make the alkyl group. So that would be beta CH3, one less C2H5. So this is C3H 7 8, sorry, this would be C3H8, I'm sorry. So this is C3H8, so one less hydrogen, C3H7. This is C4H10, so this is C4H9, and this is C5H12, this is C5H11. So by removing one hydrogen we can make the alkyl group. So this was the discussion. So this is the formula. This is again the formula. All right. Now, the next thing I'm going to discuss is about the nature of the R group. I don't want to start the isomerism because it's a vast topic. So I'll start in the next class. So, nature of the R group. What I am going to tell you, it is going to help you a lot when you will go in deep in organic chemistry. So the first nature of the R group is number one group, R group. Maybe you will not be able to understand it right now because I haven't taught you yet. but I do want to tell you about the properties of the R group. R group, that is nature of R group. Nature of R group. What is the R group? These are the R groups. These are the R group. So the first property of the R group is, which is not given directly in the books, decreases solubility. R group, which is CH3, C2H5, they decrease the solubility. Why? Because they are hydrophobic in nature. Number two, R group makes the molecule bulky or big, which causes steric hindrance. We are going to study about the steric bulky or big has a technical name which is called as steric hindrance, steric hindrance. And the third one, you will not understand this, but when we will do it in detail, because it's given in your syllabus, so I have to teach you it, teach you the topic anyway. That is, it gives positive inductive effect. What is positive inductive effect? I will discuss it later, which is also called as positive I. Inductive effect is given by I. So these are the three main properties. Now, the fourth one, I'm telling you, Zena, you will never find these properties in any book the way I am writing it. The fourth property of R group is it makes thing less acidic. Or it can you can also write it makes an acid less acidic. So these are the properties of the R group. We are going to discuss them afterward. So whatever we have done today is all clear to you, Zena? Any question, better?
No.
Have you understood it all?
Yeah.
All right. Shabash, bache. Well done. All right, Zena. Thank you so very much. Get well soon, beta. I think you are not well today. Anyway, get well soon. Take care, bache. Allah Hafiz.
Thank you. Allah Hafiz.
Allah Hafiz.